Now in this class we'll cover some of the parts of moment distribution method, remaining left out part, and the last topic related to this is this way analysis. In the last class you have seen that whatever we had, the beam, or you can say that the frame, it was in its initial position only even after the application of load. But now the today topic which we will be covering is related to sway analysis. It means that now the frame or the beam will not be in its initial position. There will be some left out unbalanced force which will cause the sway or the movement of the beam or the frame. So that sway analysis we have to perform. Why and when the sway will occur? First of all, let's understand that there are certain thumb rules. There are certain thumb rules which are related to this particular case, like when the sway will occur. First of all, if the loading is symmetrical, if the loading is symmetrical, if the loading is symmetrical about the central line, obviously, and the stiffness is also symmetrical, and the stiffness is also symmetrical, if the loading is symmetrical and the stiffness is also symmetrical, that is, if the stiffness is also symmetrical, means कि stiffness दो जगह same होनी चाहिए. For example, what is stiffness? Stiffness is rigidity upon the length. That's, for example, if this is the frame we have, like this is the frame we have, and in this frame the loading is like this. This is fixed support, this is fixed support, and there is a UVL all over throughout this particular span. Now for this particular case, if you will divide it into two different parts from the central line, you can say that the loading is symmetrical. The loading is symmetrical, it means that about the central line the loading is symmetrical, there will be no movement of the frame. कोई movement frame में नहीं आएगा, पहली चीज. दूसरी चीज, if you look about for the stiffness, अगर आप ये लेंथ L है, ये लेंथ L है, इसकी stiffness निकालते हो about the central line, if you calculate the stiffness for this part, this stiffness is, अगर आप stiffness की calculate करोगे, this is 4EI divided by L. यहाँ निकालते हो, this is also 4EI divided by L. The stiffness is also same. It means that there will be no sway in this condition, no sway. Fine. On the other hand, अगर ये frame ऐसा होने की जगह इसकी कुछ case ऐसा बनता कि if this support becomes, let's say that if this support becomes hinge support, ये fix की जगह hinge support हो जाता, तो loading is symmetrical, fine, but the stiffness will become, अभी ये 4EI upon L नहीं होता क्योंकि far end is hinged now. Now this will be 3EI upon L. Now the stiffness for this part and the stiffness for this part will become different. It means that there will be the case of sway. Always remember that the sway will occur towards the region which have low stiffness. Sway will occur towards the low stiffness region. That means that this is 3I upon L. It means that the sway for this frame will be along the right side. So you have to remember these two things, that the movement or the sway will occur only when if there is a difference in stiffness about the center line, or you can say that there is unsymmetrical loading, or that is symmetrical loading. Then the sway will not occur. If the loading is unsymmetrical, then the sway will occur. For example, if the stiffness is fine, same. If the stiffness is, let's say that same, if the stiffness is same but the loading is not symmetrical, then also sway will occur. How come? Let's see this. ये आपका फिक्स सपोर्ट है, ये आपका फिक्स सपोर्ट है, यहाँ पे आपका लोड लग रहा है. Now this is L and everything is fine, support is fine, the stiffness is fine, but if you will divide it from the central line, then you will see that because of unsymmetrical loading condition, this frame will try to move in this side. It means that there will be sway condition. So these two conditions are to be satisfied, that is symmetrical loading as well as same stiffness. अगर स्टिफनेस सेम नहीं होगी, लोडिंग सिमेट्रिकल नहीं होगी, दोनों में से कोई भी एक केस वैलिड नहीं होगा, इन दैट केस देयर विल बी स्वे. जब स्वे होता है तो वहां पे देयर इज अ रोटेशन or there is a movement with respect to a certain point. Whenever the sway will occur, then in that case there will be a movement with respect to a certain point. Let's see this. For example, if this is your beam and this is fixed support, This is also fixed support. Let's say that the condition is like this. The condition is like this. This is a fixed support. This is a fixed support. Now what exactly is happening? Due to certain loading condition, what is happening is that this support settles down to this place. ये support settle होके किसी भी केस की वजह से यहाँ पे कुछ आ जाता है. It means that at this particular point there is a certain rotation. Whenever such kind of displacement will occur, let's say that this displacement is delta, whenever such kind of movement will occur, then there will be the development of fixed end moments due to the sway or due to the displacement or due to the settlement or due to the movement. There will be the development of bending moments at the support, and those bending moments will be in the direction opposite to that of the direction of rotation. It means that if this is the direction of rotation, then the bending moment will develop like this, that is in the opposite direction of the rotation. And the value of bending moment for this particular case, this is case 1, in which this is a fixed end beam with both ends fixed. The bending moment will be, you know that anti-clockwise will be negative. This is 6EI delta divided by L square. Here also this will be 6EI delta divided by L square. If this is A, this is B, then you can say that this M bar AB anti-clockwise minus का 6EI delta divided by L square. Similarly, this will be equal to M bar BA. But the condition is that there is a certain movement, as well as this movement is in a beam which is having both the ends, or a part which is having both the ends fixed or which can handle movement. In that particular case, this will be the situation. अगर ये उल्टा settlement होता है, तो settlement is like this. If this is your fixed beam, concept समझते चल रहा. If this is your fixed beam, and in this fixed beam the settlement is not for the right support. If this is A, this is B, the settlement is for the left support. There is settlement like this. Now in this particular situation the rotation is like this. Now as I told you that the rotation is like in this direction, so the bending moment, the fixed end moment that will develop, that will be opposite to that of the rotation. This is clockwise. The value will be same because the ends are fixed. This is 6EI delta divided by L square. This is also 6EI delta divided by L square. It means that here you can say that this is M bar AB, this is equal to M bar BA, and both of these will be equal to plus ka 6EI delta divided by L square. The fixed end moments will have these values in this particular case when the ends are fixed. But if the situation is a little different, that is, the situation is little different, which means that if the beam is this, this end is fixed. Let's say that this end is fixed, but this end is hinged. This end is fixed, but the other end is hinged. ये हो गया hinged. This is A and this is B. Now what exactly is happening? This hinged end is getting settled. This hinged end is coming to here. ये यहाँ पे कहीं आ गया. There is a certain rotation. Let's say that something like this. It means that there is a rotation here. Now there will be the development of moment opposite to that of the rotation, but the moment cannot be developed at the hinge support. It means that the moment will be developed wholly at the fixed support. Also, as you know that this is the hinge support, the stiffness for this particular far end, this 3EI upon L will be the stiffness. The moment developed will be 3EI delta upon L square, because the far end is fixed but this is hinged end. So this will be, so you can say that this is M bar AB, this is equal to minus का 6EI delta divided by L square, and this M bar BA will be equal to 0, क्योंकि hinge तो नहीं हो सकता है मोमेंट. सिमिलरली अगर केस कुछ ऐसा होता कि भाई यहाँ पे भी मेरा हिंज है और मेरा जो बीम है उसका ये वाला एंड भी हिंज है, ये भी हिंज है, ये भी हिंज है, और यहाँ सेटलमेंट कुछ ऐसा होता है कि ये नीचे आ जाता है मेरा हिंज सपोर्ट. If this is also hinge, this is also hinge, there is settlement like this occurs. Then in that particular case, if you'll say कि moment कितना develop होगा, तो there will be no development of fixed end moment because the ends are not fixed. M bar AB is equal to M bar BA. This is equal to 0. This is all related to fixed end moments. तो ये fixed end moments की value हो जाती है हमारी, जो हमारी निकल के आती है. Fine. Now how to solve the questions related to this particular type, इस टाइप के जो क्वेश्चंस आते हैं, then how to solve these questions, उन क्वेश्चंस को सॉल्व करने का there is a basic way. So let's see that way through an example of a question, and then we'll proceed for more questions. What we will do some very important and different types of question, 3 different types of question, which will be on the basis of 3 different patterns, and then you will automatically understood the basic concept behind this. Fine, let's take the example of a very first question which I'll solve it, and you have to just watch it properly. बहुत ध्यान से इसको लिखते जाना, एक पेज रख लेना, कीप ऑन नोटिंग डाउन, चीज़ों को नोट करते चले जाना, ठीक है, छोटे छोटे पॉइंट्स में. फाइन, there is a support like this. This is a double roller support. This is known as double roller support. Double roller support में क्या होता है, ये bending moment लेने की ability रखता है. This double roller support can take bending moment, but it cannot take the horizontal reaction. तो इसका मतलब इस पर there are the development of 2 reactions only in this double roller support. First reaction is the vertical reaction, the second reaction is the bending moment. It can handle the bending moment. This is a double roller support which is dash here. Here this is fixed support. There is a fixed support which is dash here. There is a load of 8 kilonewton which is present at this particular end. Let's write it. This is A, this is B, and this double roller support is C. This is 8 kilonewton of load which is acting over here, and over this span BC there is the presence of UDL. UDL is present over the span BC. This UDL is 12 kilonewton per meter. This is acting over here. The dimensions are, the values are given to us. This is 2 meters, this is 2 meters, and this total is 4 meters. ये दिया हुआ आपको. Fine. आपसे कहा है the EI value, that is the rigidity. This is constant. This value is constant, and they are saying that you have to draw the bending moment diagram for this particular case. You have to draw the BMD. इसके लिए आपको BMD बनाना है. BMD बनाना आपको कैसे बनाना है मैंने आपको पहले ही बताया. BMD बनाने के लिए you have to perform the sway analysis. Sway analysis के बिना you cannot draw the BMD. Fine. Let's see this. How to proceed with this. सबसे पहले जब भी ऐसा क्वेश्चन आता है, what you have to do is that you have to perform the non-sway analysis. First of all, what is non-sway analysis? Non-sway analysis का मतलब होता है आप सारी चीज़ें भूल जाओ, ये भूल जाओ कि ये sway हो रहा है, और सबसे पहले non-sway analysis कंसीडर करके कैलकुलेशंस कर लो. non-sway analysis का मतलब क्या होता है कि सारे एंड्स को फिक्स एंड मान लो, और उसके बाद जैसे आप हमेशा करते रहते, जैसे आप अभी तक करते आए हो कि सारी चीज़ों को आपने फिक्स एंड मान लिया, सोए को भूल जाओ, और नॉन स्वै एनालिसिस जैसे अभी तक करते आ रहे हो वो गिवन लोडिंग के लिए वो एनालिसिस परफॉर्म करो. कैसे परफॉर्म करोगे देखते हैं. सबसे पहले क्यों सोए होने वाला है ये, क्योंकि मैंने आपको बताया हॉरिजॉन्टल रिएक्शन इस पर डेवलप नहीं हो सकता, तो इट मींस दैट देयर विल बी सम स्वे. इधर खिसकेगा ना, ये लोड लग रहा है, इसको इधर खिसका देगा तो पता लग रहा है मुझे लोडिंग सिमेट्रिकल नहीं है, काट लो एक्सेस, इट मींस ये स्वे होने वाला है. तो सबसे पहले व्हाट वी विल डू, वी विल परफॉर्म नॉन स्वे एनालिसिस. वी विल परफॉर्म नॉन स्वे एनालिसिस. स्टेप बाय स्टेप चलना, जैसे बता रहा हूँ वैसे ही करते जाना. नॉन स्वे एनालिसिस. फाइन. नाउ लेट्स सी दिस. आ जाओ. नॉन स्वे एनालिसिस करनी है, इसका मतलब ये है आपको सबसे पहले फिक्स्ड एंड मोमेंट्स निकालने हैं. फ्रेम आपके सामने रखा हुआ है, आप अगर फिक्स्ड एंड मोमेंट निकालते तो यू कैन कैलकुलेट दैट m बार ए बी दिस इज इक्वल टू माइनस का PL/8, दैट इज माइनस का 8 इंटू 4 डिवाइड बाई 8, दिस इज इक्वल टू माइनस का 4 किलो न्यूटन मीटर. सिमिलरली m बार बी ए दिस इज इक्वल टू 4 किलो न्यूटन मीटर. सबसे पहले फिक्स्ड मोमेंट से निकालने होते हैं आपको. उसके बाद m बार बी सी इज इक्वल टू माइनस का WL² अपॉन 8, WL² डिवाइडेड बाई 8, दिस इज इक्वल टू माइनस का 16 किलो न्यूटन मीटर. सिमिलरली यू विल कैलकुलेट m बार सी बी, दिस इज इक्वल टू प्लस का 16 किलो न्यूटन मीटर. फिक्स्ड मोमेंट्स निकाल लिए हैं. नॉन स्वे एनालिसिस करने के लिए व्हाट वी हैव टू डू इज दैट वी हैव टू जस्ट ड्रॉ अ टेबल, जैसे अभी तक करते आ रहे थे उसी तरीके से करना है. डिस्ट्रीब्यूशन फैक्टर की अगर आप बात करोगे तो डिस्ट्रीब्यूशन फैक्टर यू कैन इजीली कैलकुलेट. जॉइंट इज बी, बी पे देयर आर टू डिफरेंट पार्ट, बी ए and this is BC. Both of them can carry moment. It means that the effect stiffness for both of these will be 4EI divided by L, and for this also 4EI divided by L. इसका मतलब total will be 8EI divided by L. So distribution factor will be 1 by 2 and it will be 1 by 2. Distribution factor will be 1 by 2, 1 by 2. It means that you can perform the non-sway analysis. How you can perform? Let's see this. This is our frame and this is joint B. This is A and this is C. Fine. We have fixed end moments. We have the values. This is joint B. The distribution factors are 1 by 2 and 1 by 2. This is joint A and this is joint C. बिना पहली वाली class के this class is of no use. You have to watch the first class first and then you have to proceed for this particular class. First, second and third. Proceed step by step. Now the fixed moments are already with us. This is MR AB is minus का 4. This is plus का 4. This is minus 16 and this is plus 16. These are the values which are with us. All of these can take the value. अगर ये hinge होता तो मैं 16 को minus करके फिर वापस लेके आता, उसको correction करता. Fine. Now the unbalanced moment. Let's see, check about that. Minus 16 plus 4. So it means that minus 12 is basically the unbalanced moment. So it means that plus 12 will be the balanced moment which had to be distributed half and half. तो प्लस 12 का आधा 6 यहाँ पे, आधा 6 यहाँ पे, आधे 6 का आधा यहाँ पे, आधे 6 का आधा यहाँ पे. These will be the values. It means that the final values after distribution will be, you can calculate the final values. These will be the final non-sway moment. This is non-sway moment. Non-sway moments. These will be minus 4 plus 3. This is minus का 1 kilonewton meter. This is 10 kilonewton meter. This is minus का 10 kilonewton meter. And this is plus का 19 kilonewton meter. तो नॉन स्वे मोमेंट्स we have already done with. ये कैलकुलेट कर लिया है. सबसे पहले क्या करना है? फिक्स्ड मोमेंट निकालना है, डिस्ट्रीब्यूशन फैक्टर निकाल के नॉन स्वे मोमेंट्स निकाल लेने हैं. इतना कर लिया. Now after this what you have to do is that you have to calculate the reactions. You have to calculate the reaction. अब आपको करनी है reactions calculate. How to calculate the reactions? वन बाय वन मोमेंट आपके पास है, नॉन स्वे एनालिसिस आप कर चुके हो. इनका यूज करके गिवन लोडिंग के अकॉर्डिंग यू हैव टू कैलकुलेट द रिएक्शन. फॉर एग्जांपल वी हैव फर्स्ट पार्ट ए बी. दिस इज फर्स्ट पार्ट ए बी. दिस इज फिक्स्ड. ये आपका ए बी पार्ट है. दिस इज ए and this is B. There is a load of 8 kilonewton which is acting like this. 8 kilonewton is acting. You have already have moments. We have AB. Minus का 1. Minus 1 means anti-clockwise. This is 1 kilonewton meter. We have B8. Positive का 10. This is 10 means clockwise kilonewton meter. This A will have two reaction. एक यहाँ पे HA लगेगी, एक यहाँ पे RA लगेगी. Let's say that this is HA. And in this direction this is RA. तो सोए बेसिकली हो रहा है ये राइट साइड में, तो RA का कोई इफेक्ट नहीं है. तो बेसिकली व्हाट वी हैव टू डू इज दैट वी हैव टू कैलकुलेट द वैल्यू ऑफ HA. HA चाहिए. HA कैलकुलेट करने के लिए व्हाट वी कैन डू इज दैट वी कैन यूज समेशन ऑफ मोमेंट. अभी आप कौन से स्पैन की बात कर रहे हो? AB की. मोमेंट अबाउट B इज इक्वल टू 0. When you will use summation of moment about B is equal to 0, it means that you will hold this. This is taking it inside. It means that it is creating sagging. Hogging, it is creating hogging. HA is creating hogging. इसको होल्ड करोगे, अंदर लेके जा रहा है, हॉग करेगा आउटर फेस में. तो माइनस का HA into the distance is 4. This 10 is creating what? This 10 is creating sagging. This is plus का 10. This one is again creating hogging. This is minus का 1. This is what? This is minus का 8 into 2. This is equal to 0. From here what you can do, you can calculate the value of HA. This HA value when you will calculate, this is equal to minus का 1.75 kilonewton. This is HA. ये आ गया आपका HA माइनस का 1.75. फाइन. सिमिलरली व्हाट यू कैन डू इज दैट, क्योंकि आपको पता है ऊपर वाले जो आपका है जो डबल रोलर सपोर्ट है, इसमें हॉरिजॉन्टल रिएक्शन नहीं आती है, तो HC विल नॉट एग्जिस्ट. इट मीन्स दैट द HA वैल्यू इज दिस मच. नाउ व्हाट वी हैव टू डू इज दैट you have to calculate the resultant unbalanced force. रिजल्टेंट, क्योंकि स्वे राइट में कर रहा है तो वी हैव टू कैलकुलेट रिजल्टेंट हॉरिजॉन्टल, राइट में स्वे कर रहा है तो रिजल्टेंट हॉरिजॉन्टल अनबैलेंस्ड फोर्स, unbalanced force, we have to calculate that resultant unbalanced. It means that right side में sway कर रहा था, right side में क्या क्या लग रहा है आपका, तो resultant unbalanced force will be fx summation fx, this is equal to 8 minus का 1.75 and this value is equal to 6.25 kilonewton. This is resultant unbalanced force. So you can say that the sway force जिसकी वजह से स्वे हो रहा है, जिस फोर्स को आपको ख़त्म करना है, दिस स्वे फोर्स इज इक्वल टू 6.25 किलो न्यूटन इन द राइट डायरेक्शन. दिस इज द स्वे कॉजिंग फोर्स. इस अनबैलेंस फोर्स की वजह से स्वे हो रहा है. 8 लग रहा है राइट साइड में, एच लग रहा है माइनस का अपोजिट साइड में, मतलब तो 8 minus 1.75 is basically the force which will be acting, that is causing the sway. That is basically the reason behind the sway. Now you have performed the non-sway analysis, you have calculated the sway causing force. सबसे पहले आपने माना sway नहीं हो रहा है, फिर आपने सब कुछ कैलकुलेट किया. You have considered that there is no sway and you have calculated each and every bending moment in that particular condition. And using those values of bending moment, you have calculated the additional unbalanced force, that is basically the reason behind the sway. अगर ये जीरो हो जाता तो इसका मतलब sway हो ही नहीं रहा था, जो आपने माना था वो सही था, बट आपने कंडीशन अज्यूम करके चला sway नहीं हो रहा है, बट एक unbalanced force निकल के आ गई, means that there is a sway. Now what we have to do is that you have to perform the sway analysis. You have already done with the non-sway analysis. Now you will perform the sway analysis because you know that the sway force is present. That value of sway force is 6.25 kilonewton. This is 6.25 kilonewton. This is the value of the force which is causing sway. इसकी वजह से sway हो रहा है. Fine. Now, how to perform the sway analysis? In order to perform the sway analysis, you have to remove all the loading conditions and apply the value of the sway force at the top. Remove all the loads and apply. सबसे पहले नॉन sway करके sway force निकाल लिया and apply the sway force S जो आपने अभी निकाला है, and apply the sway force at the top. कैसे? We have this particular frame. This is the frame which we have. This is the frame which we have. धीमे धीमे क्यों समझा रहा हूँ, जिससे आपको सारी चीजें ग्रास्प करते चले जाओ. This is the case which we have, and this was the fixed support, and this was the double roller support. ऊपर लाइन यहाँ खींच दो, यहाँ खींच दो. This is C, this is A, and this is B. Now what you have to do is that you have to remove all the loads, and what we have to do, we have to apply a sway force at the top. That is, we have to apply a force here. And what is this force? This force is basically the sway force S, जो आपने कैलकुलेट की है. Fine. Now लोडिंग सारी हटा दी है, sway लगाया है. जब ये फोर्स sway वाली, बहुत ध्यान से सुनना इस चीज को, when this sway force will act at this particular point, this cannot handle the horizontal force. It means that the frame will move in the right direction because of this unbalanced force of 6.25 kilonewton. The frame will move in the right direction, but this is fixed support. It means that the fixed support cannot move. So here this AB panel will move like this. The AB panel will move somewhat like this. This will be the movement of this AB panel. ये इतना आगे जाएगा AB panel, and this C point will move here, and this will reach this particular point. It means that there will be a extension here also, there will be a movement here also. If this is delta, then this will also be delta. जितना ही आगे जाएगा उतना ही ये खींचेगा. इसको पकड़ के C से खींच रहे हो आप, C आगे चला गया, यहाँ कितना डेल्टा आगे आ गया. देखने में थोड़ा ज़्यादा लग रहा है, कोई बात नहीं, इतना तो चलता है अभी, ठीक. This is C. It means that this is delta, then this is also delta. Now we already know that if this point A is being rotated like this, बहुत ध्यान से सुनते चले जाना एकदम. If this point A is rotated like this, and it means that there will be the sway moment development in this particular direction and this particular direction. समझ में आ रहा होगा. There will be the development of the sway moments. And what are the sway moments? You already know the values. We have already calculated these values. This will be 6 EI delta, जितना ये बड़ा है, divided by L square, and this will also be 6 EI delta divided by L square, because this can also take moment, this can also take moment, both of these can take moment. Fine. Now this is for AB, but BC is going like this. It is moving linearly like this. It means that there will be no development of the moment, because the development of moment only will be present only when there is some kind of rotation. Rotation होगा तभी तो moment होगा. यहाँ rotation है नहीं, that means that there will be no moment to be developed here. Fine. Now let's write these sway moments. It means that I can say that in the case of sway, this M bar AB, this is equal to this M bar BA, and both of this will be equal to minus का 6 EI delta divided by L square. Both of these will be equal to this, and this M bar BC, which will be equal to M bar CB, this will be equal to 0 होगा. Now it means that if I'll consider a certain ratio, that this M bar AB is to this M bar BA is to this M bar BC is to this M bar CB. If I'll consider this ratio, then this ratio will be minus का 6 EI delta divided by L square is to minus का 6 EI delta divided by L square is to 0. Or we can say that this will be equal to minus का 1 is to minus का 1 is to 0 is to 0. It means that this will be the ratio of the sway moments. Now in order to have an easy calculation, what we can do is that we can multiply this total equation. Total equation means this is the ratio equation with 8. Let's multiply this with 8. Multiply this with 8. What you will get? We will get this ratio is equal to, this ratio will be equal to minus का 8 is to minus का 8 is to 0 is to 0. ये आपके मोमेंट आ गए, sway moments हैं ये. Now what we will do is that we will distribute these moments, जो आपने sway moments निकाले हैं. Now you will distribute these moments. How you can distribute? Again the same method, same procedure जो अभी तक करते आए थे. You have to stretch a line like this. This is a joint B. This is point A. This is point C, and this is joint B. The distribution factors are 1/2, 1/2 depending upon the stiffness, which we have already calculated. This value of moment at point A, B and point BC and CB, you have to write it here. So let's write these values. These values will be M bar AB is equal to minus 8. क्योंकि यार 8 से मल्टीप्लाई ईजी हो जाता है, 1 से भी डिस्ट्रीब्यूट करोगे तो बहुत छोटी छोटी वैल्यूज हो जाएंगी. This is again minus 8. This is 0 and this is 0. Now what is the unbalanced moment here? If you will see that the unbalanced moment at the joint is basically minus 8, it means that this minus 8 has to be converted into the balanced moment of plus 8, which has to be distributed half and half in both the sides, that is 4 and 4. This 4 will come here, this is 2, and this 4 will also go there, this is 2. Why it will go there? Because both of the parts can take the moment. This can also take the moment and this can also take the moment. अगर नहीं ले सकता तो नहीं भेजते उसको. It means that the final sway moment, or you can say that the final moments after this calculation, which are exactly not the final moment, so we'll write it column. इसको जनरल डायरेक्शन में लिखते हैं, जनरल लैंग्वेज में column A. This is referred as column A. So these values will be minus का 6 kilonewton meter, and this is minus का 4, this is 4, and this is 2. It means that the column A moments are this. These are the column A moments. Now again what you have to do is that you have to use these moments. You have to use these moments, and then you have to calculate the reactions at the supports. Again the same case. लंबा क्वेश्चन आता है, 20 नंबर का आता है कम से कम. What we have to do is that we have to again calculate the reactions. Reactions निकालनी है. कैसे? सबसे पहले आपके पास पार्ट था, you had AB. AB was the first part of the frame that was with us. This was the fixed support, and because as you know that the sway was in the right direction, so we are considering this is the force which is HA in this particular direction. This is present here, this is HA. Fine. Now let's draw the moment. Pending moment बना लो. This is minus का 6, which is means it is anti-clockwise 6. This is point A. This is point B. This is minus का 4. It means this is also anti-clockwise 4 kilonewton meter. लोडिंग आपने रिमूव कर दी. यू हैव टू रिमूव द लोड. लोड आप इसमें हटा ही नहीं रहे हो. जब आप स्वय एनालिसिस कर रहे हो तो लोड आपने पहले से हटा के एस लगा रखा है ऊपर. ठीक है, यहाँ आपको ऑलरेडी एस लगा हुआ है. यू ऑलरेडी नो दैट कि एस इज प्रेजेंट हियर. ठीक. What we are doing, we are again considering summation of moment about B is equal to 0. You can again use the same thing. This is minus का, let's say that this is HA dash and let's say that this is S dash here. HA पहले लिया था ना, तो H dash minus का HA dash into 4 minus का 6 minus का 4. This is equal. Now from here if you will calculate this HA dash, this HA dash will be minus का 2.5 kilonewton. If this HA dash is minus 2.5 kilonewton and this is S dash, by using equilibrium equation that summation Fx is equal to 0, this S dash plus HA dash, this is equal to 0. It means that this S dash is equal to 2.5 kilonewton. It means that this S dash is equal to 2.5 kilonewton. ये आपकी वैल्यू निकल के आ गई है. ठीक. फाइनल मोमेंट निकालने के लिए कि भाई कोई भी सोए ना हो, इन दैट केस व्हाट यू हैव टू डू इज दैट, ध्यान से समझते जाना, फाइनल मोमेंट्स विल बी, in order to calculate the final moment, the relation which you have to use is that the final moment is equal to the column A moments into S जो आपने पहले निकाला था डिवाइडेड बाय S dash. कॉलम ए वाले जो मोमेंट है उनको S अपॉन S dash से जब मल्टीप्लाई करोगे you will get the final moments which will be present here. वो आपके फाइनल मोमेंट्स हो जाएंगे. उन मोमेंट्स का यूज करके you can draw the BMD finally. It means that सबसे पहले आपने SO एनालिसिस, नॉन SO एनालिसिस किया. इसमें आप नॉर्मली सबने you have considered that the fixed supports will be present, loading is also present. You have done each and everything. You have calculated the unbalanced force. This is S 6.25. After that, what you will do is that you will provide a certain force here in this particular point, and you will do the sway analysis. After doing the sway analysis, you will calculate the ratio of the sway moment because of the rotation that will only be present. You will calculate the ratio, then you will distribute the moment depending upon that ratio. You will calculate. यहाँ पे जरूरी नहीं है 8 है, you can multiply anything. It's not like कोई जरूरी नहीं है 8 से multiply करो. मैंने अपनी ease के लिए किया हुआ. Then what you do is that you will calculate the value of the column A moment by distributing that particular जो आपने ratio निकाला है. Using those column A moment, you will calculate the value of S dash that has to be applied at the top. And after that, in order to calculate the final moment, you will multiply the column A moment with S upon S dash. It means that the final moments which we will get after doing all these things, the final moments will be, अगर आप final moment निकालते तो कुछ इस तरीके से होगा. This point is A, this is B, and this is C. Column A into S upon S dash means this is column A. S upon S dash. S का मतलब 6.25 और S dash का मतलब 2.5. You have to multiply each and everything with these ratio. तो S upon S dash का ratio निकाल के उसको multiply कर देना. When you will multiply this, so the final sway moment which you will get after doing all this, column into S upon S dash करने के बाद जो final values आपके पास आएंगी, these values will be minus का 15 here, this is minus का 10 here, this is 10 here, and this is 5 here. This will be the value. Fine. अब आपको क्या करना है, आपके पास ये वैल्यू तो मल्टीप्लाई करने के बाद आ गई. Now you had नॉन sway moments also. ये कौन सी वैल्यूज हो गई, ये हो गई आपकी कॉलम A इंटू S अपॉन S डैश. नॉन sway moments आपने पहले निकाले हुए थे, वो आपके पास ऑलरेडी थे. दिस वॉज -1, दिस वॉज +10, this was -10, and this was plus का 19. These were the non-sway moments. Now what we have to do is that you have to add these two values. इन दोनों को आपको ऐड कर देना है in order to get the final resultant moments. In order to get the final resultant moments, इनको final मत लिखो, चाहो तो कंफ्यूज हो जाओगे. इनको final मत लिखो, इनको moments लिख लेते हैं हम. final इनको लिख लेते हैं that the final resultant moments This will be minus 15 minus 1. This is minus का 16. Minus 10 plus 10. This is 0. This is 0 and this will be 24. These will be the values. Now what we have to do is that if you want to draw the BMD, then you can draw the BMD using these values. How you can draw? Let's see this. This is the frame which we have. 3-4 बार फ्रेम बन गया. ये बस थोड़ा सा इसमें टिपिकल पड़ता है. पहला क्वेश्चन है इसलिए इतना टाइम लगा रहा हूँ. नेक्स्ट क्वेश्चन से टाइम नहीं लगाऊंगा, फटाफट से बना दूंगा. आपको समझाने के लिए मैंने टाइम लगाया है. दिस इज अवर रोलर सपोर्ट, दैट इज डबल रोलर सपोर्ट. दिस इज दिस लाइक दिस, दिस इज लाइक दिस. दिस इज ए, दिस इज बी, दिस इज सी. माइनस 16 मतलब एंटी क्लॉकवाइज, माइनस का 16. दिस इज 0, दिस इज 0 मतलब ही नहीं है. इस पे आ रहा है 24 पॉजिटिव का. दिस इज 24. बेंडिंग मोमेंट बनाना है. बेंडिंग मोमेंट बनाने के लिए मैंने आपको कॉन्सेप्ट पहले ही समझाया हुआ. व्हाट इज द कॉन्सेप्ट? जिस पे देख रहा हूँ, इसका इफेक्ट देख रहा हूँ, इसको पकड़ो, होल्ड किया मैंने. ये क्या कर रहा है? इसको अंदर लेके जा रहा है, हॉक करा रहा है. हॉक कराने का मतलब नेगेटिव, अंदर लेके जा रहा है ना. हॉक कराने का मतलब नेगेटिव, नेगेटिव का मतलब कहाँ जाएगा? ये बाहर बनेगा. दिस विल बी लाइक दिस. ये आ गया इसका इफेक्ट 16 का. अंदर लेके जा रहा है हॉक, हॉक का मतलब बाहर, बाहर का मतलब नेगेटिव. इसको पकड़ो, ये तो 0 ही है. इसको पकड़ो, ये क्या कर रहा है? हॉक करा रहा है, हॉक का मतलब बाहर. इसका मतलब ये भी ऐसे ही जाएगा. दिस विल बी 24 लाइक दिस. इसके ऊपर क्या था? यूडीएल था. यूडीएल आपके पास इसके ऊपर रखा हुआ था, जिसका वैल्यू की थी 12 किलो न्यूटन मीटर. इसका मतलब यूडीएल का तो आप जानते हो क्या बनता है, आपका पैराबोला बनता है कुछ इस तरीके से. लेट्स से दैट दिस इज द पैराबोला व्हिच विल बी डेवलप हियर लाइक दिस. एक पैराबोला बनेगा. ये आपका हो गया 16 किलो न्यूटन मीटर. दिस इज योर 24 किलो न्यूटन मीटर. इसकी बात करते हैं. इस वैल्यू को निकालना है मुझे. आई वॉन्ट टू कैलकुलेट दिस वैल्यू. इट मीन्स दैट दिस वैल्यू विल बी W इंटू एल, टोटल लेंथ. स्पैन के मेरे पास लेंथ क्वेश्चन में गिवन था. एक मिनट चेक कर लेते हैं कितना गिवन था. 4 गिवन था. दिस इज 12 इंटू 4 इंटू 4 WL² डिवाइडेड बाई 8 माइनस का 24 प्लस 0 डिवाइडेड बाई 2. तो दिस 4 2 is 8, 2 6 is 12, 6 4 is 24 minus 12. So this will be 12 kilonewton meter. This is 12 kilonewton meter. Now what we have to do is that you have to shade the uncommon portion. This total is uncommon. Uncommon portion को shade कर दो, बन गया अपना. This is our bending moment diagram. Sway analysis, how to perform the sway analysis. This is a basic concept on that. Just practice this concept. I'm now not continuing more question in this lecture, otherwise you'll get confused. I will be uploading the questions on this particular topic in the next lecture. Till then, just write this question and practice it properly so that you can easily grasp the question which I'll be providing in the next coming lectures. This is A.S. Pandey signing off this session. Take